Hello and welcome. In this video, we're going to talk about limits. We're going to learn what they are and how to identify them from a graph. So our learning objective in this section is that I can find the limit of a function from a graph or identify if it does not exist. Let's go ahead and jump right in. So let's start by defining what a limit is. A limit describes the y value that a function approaches at a given x value. So as we get closer and closer to x being 5, what's happening to the function? As we get closer to x being 6, what's happening in the function? That's really similar to just evaluating a function, plugging a number into a function. In order to determine the limit of a function, we're going to look at how the y values are changing both from the left and the right side of the x value that we care about. So a couple logistical things I just want to make sure we understand before we jump in. We're going to talk about notation first. So this is what limit notation looks like. This reads, or how we would say this out loud, the limit as x approaches c of f of x. So pause the video and maybe write that down. The limit as x approaches c of f of x. That's how you would say this out loud. So if I wanted you to find the limit as we approach 2 or 7, you're going to see a number pop in right there. The next thing that I want to mention is that not every function has a limit that exists at every particular value. Sometimes there's an issue with continuity, sometimes there's a vertical asymptote. So there's a handful of reasons, which we'll discuss in a future section, about why a limit doesn't exist. But if a limit doesn't exist, meaning the limit is not approaching a finite value, we can write DNE for does not exist. And lastly, just getting on a notation and definition page here, lastly, we might be looking at one-sided limits. We might be looking at what happens just as we approach a value from the left, which would mean we would write it like this, with a little superscript here meaning minus, and that is from the left. For the right, it's going to look exactly the same, except there's going to be a little superscript plus sign, which is indicating we're approaching that limit from the right. So go ahead and fill these same pieces of information in on your paper and make a note of anything that you're worried you might forget. And then let's actually look at some examples. Let's look at some graphs and identify some limits. All right, so here we have the graph of a function f, and a lot of different things are going on. We have some holes, we have a vertical asymptote, we have what's called a jump discontinuity, which don't worry, we're going to formalize all those definitions in a different video. But what we're really just going to do is we're going to look at the graph and we're going to identify the limit that we're being asked about. So this says the limit as x approaches -4 of f of x. So if I'm looking at the graph and I'm getting close to -4, as x gets close to -4, the graph is approaching 1. In fact, the graph is 1. If we look at what's happening as we approach -1, now here, the function is equal to 1 when x is -1, but what's happening as we get close from the left and from the right is we're getting really close to the number 4. So the limit as x approaches -1 of f of x is going to be 4, even though the value f of -1 is actually 1, because we're saying what value are we approaching, and the value we're approaching is 4. So I'm going to just make a little note here also. We're paying attention. We're noting that f of -1 is not 4, but the function is approaching 4, both from the left and the right, as x approaches -1. The limit as x approaches 2 of the function, same scenario here. As we approach 2 from the left and as we approach 2 from the right, what y value are we approaching? We're approaching 1. And we can go ahead and note also that f of 2 doesn't exist. So the limit can exist. And I'm just making this as a note. This is not the answer to the question. The limit can exist even if the function doesn't exist at that particular value. Let's go ahead and look at a few more examples. All right, here we're looking at the same graph, and now we're looking for certain values of the function. So notice these 4 don't actually have a limit, and then 2 limits related. So I want you to go ahead and pause the video and see which of these you can do on your own, and then unpause the video and see how you did. Remember, if something doesn't exist, you can simply write DNE for does not exist. All right, hopefully you had enough time to work through that. F of -4 is going to be 1. F of -1, we talked about this already, is going to be 1. F of 2, we also talked about this, does not exist because there's no filled in point somewhere. If there was a point right here, sort of like there is at x equals -1, then we could identify f of 2. But there's no open circle filled in anywhere, so f of 2 does not exist. The limit as x approaches 3 does not exist. I'm going to make a little note. We're getting really close to a vertical asymptote, so we'll talk about that a little bit more in another section. The limit as x approaches 5, well, from the left, it's getting really close to -1, and from the right, it's getting really close to 2, and those are not the same number, so this limit is not going to exist. Even though f of 5 does exist, f of 5 is equal to 2. So go ahead and pause the video, make sure you have those answers correct, and we're going to do just a couple more with this same graph, and then we'll wrap up. All right, last 3. Again, I'm going to encourage you to pause the video and work through these on your own. All right, hopefully you had time to do that. F of 3 does not exist, again, because there's a vertical asymptote there. The limit as x approaches 5, and this little plus sign means from the right, so if I'm approaching 5, from the right-hand side, I'm getting really close to y equals 2. If we're approaching 5 from the left-hand side, coming at it from the left, our function is approaching -1. So y is getting closer and closer to being -1. All right, now that we finished these examples, let's go ahead and wrap up this video. All right, so in this video, 1.2, we talked about how to identify a limit of a function from a graph or identify that that limit does not exist. We looked at one-sided limits approaching from the left or from the right. We looked at two-sided limits where we had places where the function was not continuous, and we tied that all together around a graph. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.